Hello, today we are going to learn how to integrate square root of tan x. Now before we move on to this, we would like to understand a few formula. If we have x minus 1 by x the whole squared, now it gives us x squared plus 1 over x squared and minus 2 because 2 times ab makes it a 2. And if we have x plus 1 over x whole squared, it gives us x squared plus 1 over x squared and plus 2. So we should be using these two formulas. Number 3, if we have x, the derivative of x minus 1 over x, it gives us 1 plus 1 over x squared, and the derivative of x plus 1 over x gives us 1 minus 1 over x squared. And then the formula for ln 1 over a square plus b square, and the derivative the formula for 1 over x square minus a square. So if we have integration of 1 over x square plus a square, the formula is 1 over a tangent inverse x over a. And if it is 1 over x square minus a square, the formula is 1 over 2a ln x minus a over x plus a, and of course plus c as far as integration constants are concerned. Now once we know this, we would start by assuming for tangent. So I'm going to keep these formula on one side. Now let us begin with, so because we have a square root of tan x, what we are going to do is we are going to assume let tangent of x equals to u square. Now differentiating both the sides, we get sec squared x dx equals to 2u du. Now we get dx, dividing both the sides by sec square x, we get 2u du over sec squared x. But we know sec squared x can be written as 1 plus tan squared x. So we write 1 plus tan squared x in place of sec squared x. But according to our substitution, tangent of x is u squared. So this becomes 2 du over, and then 1 plus, now tangent square will become u to the fourth. Now we shall go in for our substitution. So now our integration I becomes integral. Now square root of tan x means square root of u squared, and in place of dx we write 2u du over 1 plus u to the power 4. Now square root of u square is 2u. Square root of u square is u times 2u gives us a 2u squared over 1 plus u to the power 4 du. Now over here, because we have 1 plus u to the power 4 in the denominator, in the numerator we should have u squared plus 1 and u squared minus 1. And so we break up 2u squared as u squared plus 1 plus u squared minus 1 whole over 1 plus u to the power 4 du. And then we separate the two integrals. We write u to the power 4 plus 1, I'm sorry, u squared plus 1 over 1 plus u to the power 4 du and plus, and we write the second one as u square minus 1 over 1 plus u to the power 4 du. And we name the two integrals as I1 plus I2. Now we shall go on to solve them one by one and step by step. Now in the next step, we are going to take up I1 and integrate that. Now I1 equals integral u squared plus 1 over 1 plus u to the power 4 du. Now what we do is we divide the numerator and the denominator by u square. So in the numerator, u square over u square gives us a 1 plus 1 over u square over u square plus 1 over u square and du. Now, because in the numerator we have 1 plus 1 over u square, and 1 plus 1 over u square is the derivative of x. Over here, if you look at this, is the derivative of x minus 1 over x. So over here, we are going to change the denominator as u minus 1 by u the whole squared and plus 2. Because u minus 1 over u whole square will be x squared plus 1 over x squared minus 2. So if we bring in 2 to the left, it becomes a plus 2. Now once again we are going to assume let u minus 1 over u equals to v. Now if we take the derivative using this one, it becomes 1 minus plus 1 over u squared du equals to dv. Now we shall substitute in this. So we have I1 is equal to integral. Now the denominator becomes 1 over v squared plus 2, and the numerator along with du, which is this, becomes a dv. Now this looks like 1 over v square plus square root of 2 whole squared dv. Now this represents this formula 1 over x square plus a square dx, and so using that formula 1 over a tangent inverse v over root 2 plus c1, and that gives us 1 over root 2. Now resubstituting the value of v, the value of v will be this, and we take the LCM, so it becomes u square minus 1 over u. So this will be u squared minus 1 over square root of 2u and then plus c1. Now once we already have the substitution as u over there at the beginning. Now u is square root of tan x and u square is tangent x. So this will be tangent x minus 1 over square root of 2 tangent x and then plus c1. So that is how we are going to integrate I1. Now we shall go on to integrate I2. Just a minute. Let us shift it so that we have more space over here. Now we shall integrate the second part, that is I2. Now we have I2 equals to integral u squared minus 1 over 1 plus u to the fourth, and then dividing by u square on the top and the bottom, we get 1 minus 1 over u square over u square plus 1 over u square du. Now once again going back to the formula, x plus 1 over x, because we have 1 minus, so 1 minus 1 over u square will be like this. So we will use x plus 1 over x. So this gives us integral 1 minus 1 over u square over u plus 1 over u the whole squared minus 2 du. Assuming u plus 1 over u as, say, w. Now differentiating, we get 1 minus 1 over u square times du equals to dw. Substituting in the equation, we get I2 is equal to integral 1 over w squared minus 2 and then dw, because the complete numerator along with this du becomes dw. Now this is integral 1 over w square minus root 2 squared dw, and that will give us, using the second formula, we have 1 over 2 root 2 ln w minus root 2 over w plus root 2 d, sorry, not plus c2, plus c2. Now we will substitute the value of w, and the value of w will be u squared plus 1 over u equals to w. So in place of w, I write u squared plus 1 over u goes with root 2u after taking the LCM, and u square plus 1 plus root 2u, and the u in the denominator gets cancelled because it is there in the numerator and the denominator. Now we shall plug in the value of u. We know the value of u is square root of tangent x. So u square will be tangent of x plus 1 minus root 2 tangent of x whole over tangent of x plus 1 plus square root of 2 tangent x, and then plus c2. And so on the whole, the complete solution for square root of tangent of x will be I1 plus I2. So now we shall write it as integration of square root of tangent of x dx equals to 1 over root 2 tangent inverse tan x minus 1 over square root of 2 tangent x plus the second one 1 over 2 root 2 ln tangent x plus 1 minus square root of 2 tangent x whole over tangent of x plus 1 plus square root of 2 tangent x, and the c1 plus c2 becomes another constant c. That shall be the final answer for square root of tangent of x. I'm sure you followed all the steps. If in case you have any questions on this, you may post it in the comment box and I shall be there to clarify this. Thank you for watching.